In this video, we're going to be solving absolute value inequalities. We're also going to be able to graph and then distinguish between an and or an or situation. So we want to take a look at how does this relate to yesterday when we did our absolute value equations. Well, first of all, when we did our absolute value equations, there were two solutions, and that will also be true today when we have inequalities, that there are going to be two solutions. Secondly, when we take a look at compound inequalities that we had before, we came up with either an or situation or an and situation. And when we had the or situation, we were graphing two separate sections on the number line. And when we had our and situation, that was where we had our range that was shaded. And that we will discover today is the same type of situation when we're doing our absolute value inequalities. We're either going to have an or situation or we're going to have an and situation. Let's take a look. So when we have the absolute value of x, if we were to come up with a solution for this, as we were working on yesterday with our equations, x would be less than 7. We also know that x would be a negative 7, and we would need to flip the sign. So if we were to graph this situation, we'd draw our number line, and we'd have our two tick marks for our solutions, one at negative 7 and one at positive 7. At positive 7, we have an open circle and it's less than, so we're shading to the left. At negative 7, we also have an open circle because it's greater than, and numbers that are greater than shade to the right. So we can see that an and situation is a compound where we are having our range. And if we write that as our compound inequality, we will have our range where our variable is in the center. This is a situation when it is less than of an and. Let's take a look at what happens when we have greater than negative 7, the absolute value of x. So if we write out our two situations, we have x being greater than negative 7, and then we have x, we need to flip the inequality symbol, and we have a positive 7. Now if we graph that, we should see that our case is the same as what we did before. We have our tick marks at negative 7 and we have our tick mark at positive 7. And when we have greater than negative 7, we have our open circle shaded to the right, and we have our open circle at 7 shaded to the left. So we can see that we have the same situation as we did in our first example, and we can write that out as our compound inequality. What happens if we have the absolute value of x is greater than just 7? So let's write out our two situations. We have x greater than 7, and we have our x being less than negative 7. If we graph that on the number line, we can see that we have our negative 7 and our positive 7, and both of these have open circles. When we have x is less than negative 7, less would be to the left on the number line. And when we have our open circle at positive 7 and it says x is greater than, we're going to be shading to the right. So this is our situation where we have our or, meaning we have our two separate areas. So using that information, let's start solving some of our absolute value inequalities. Okay, so we have d is less than 3. So we need to first make sure that our absolute value sign is isolated and by itself, and then we set up our two situations. So we have d is less than 3, d is greater than negative 3. Let's take a look and graph. So we draw our number line with our two tick marks, one at -3 and one at +3. Both are going to be open circles, and when we have D being greater than -3, we're shading to the right, and D being less than 3, we're shading to the left. This is an AND situation, so we need to make sure that we rewrite our inequality as our compound inequality with our variable in the center showing that it is an AND situation. Next example, again making sure that our absolute value is by itself, and it is, so we'll set up our two cases. T minus 4 is less than or equal to 7. T minus 4, flip the sign, is greater than or equal to -7. So solving, we do the opposite operation by adding 4 to both sides, and we have T is less than or equal to 11. In this situation, we're going to add 4 to both sides, and we have T is greater than or equal to -3. So we're going to graph our absolute value inequality, and putting our tick marks at -3 and +11. We have a closed circle at -3, and it says T is greater than that, so we're shade to the right. And on the 11, we have our closed circle, and we're going to shade to the left because it's less than. So again, we have an AND situation for our compound inequality. It is a range, so we need to make sure that we finish our problem by writing out our compound inequality, demonstrating our AND situation. In the next example, the absolute value again is already by itself, so we'll set up our two cases. We have 2x minus 7 is greater than or equal to 9, and we have 2x minus 7 is less than or equal to -9. So to solve, we're going to add 7 to both sides of our inequality, doing the opposite operation. So we have 2x is greater than or equal to 16, and then we're going to divide by 2, the opposite operation. Keeping our inequality facing the same direction, we have x is greater than or equal to 8. Add 7 to both sides, the opposite operation. We have 2x is less than or equal to -2, and then we're going to divide both sides by 2. So we have x is less than or equal to -1. Let's graph this, putting our tick mark at -1 and at +8. We have a closed circle at -1, and it says x is less than or equal to. So that means x is smaller. We're going to shade to the left. A closed circle at 8. X is greater than or equal to. Numbers that are greater than are shaded to the right. Notice we have our two separate sections being shaded, so this is an example of an OR situation, and we'll need to make sure that we put that word there so that we understand that one. In this example, we need to isolate the absolute value, so the first thing we'll do is to get rid of that 4 by subtracting 4 from both sides. So the absolute value of x plus 1 is greater than -2. Now that the absolute value is by itself, we can set up our two situations. X plus 1 is greater than -2, and x plus 1, by flipping the sign, is less than +2. So we subtract 1 from both sides, and we have x is greater than -3. Subtract 1 from both sides, and we have x is less than 1. Graphing this absolute value situation, we have tick marks at -3 and at +1. So we'll do an open circle at -3 and an open circle at +1. Our situation says x is greater than -3. If x is greater, we're going to shade to the right, and since it's less than 1, we're going to shade to the left. This creates our compound inequality that's an AND situation. So we need to rewrite showing that range. On the next example, we need to get the absolute value by itself. So the first thing we'll do is to do the opposite operation, which is to add 5. So now we have 2 times the absolute value of x minus 3 is less than or equal to 12. And then we're going to divide both sides by 2. So now we have our absolute value of x minus 3 is less than or equal to 6. Now we can set up our two situations. X minus 3 is less than or equal to 6. And x minus 3, flipping the sign, is greater than or equal to a negative 6. We'll add 3 to both sides. And so we have x is less than or equal to 9. And when we add 3 to both sides in this situation, we have x is greater than or equal to negative 3. Let's graph. Tick marks at negative 3 and positive 9. Closed circles on both. And it says x is less than or equal to 9. So the numbers that are less than go to the left, and when it's greater than negative 3, we shade to the right. This is a situation which is and on our compound inequality. So we'll need to rewrite that to demonstrate that with our variable in the middle. So let's review. Absolute value inequalities are similar to absolute value equations and to compound inequalities. Remember, if it's an and situation, we're shading inward. If it's an or situation, we're shading outwards. Two inequalities, when solved, then make into the compound inequality. And be sure that you flip the sign when you're multiplying or dividing by a negative number. As you finish the notes, be sure to move on to the reflection.